All right, guys, happy Monday. Before I forget, don't forget to like and subscribe, right? That's what YouTubers say. So do that. Just kidding. Um, Today we're going to be starting the mid-chapter review for a test. Your test is going to be a week from today. So we'll have a couple of days for you to work on the review problems. Then I'll post those on Wednesday. You'll check your answers, make sure you're getting things correct, ask questions as needed. Make sure you reach out to me if you're missing some stuff. Then I'll have an online practice test Thursday. We'll have our Kahoot on Friday, and it won't be a live Kahoot. You can kind of do it at your own pace. And then your test will be Monday. So make sure you're asking questions on whatever you need to get yourself ready for that test. So we'll go ahead and dive into this. I'll do a few examples from each section, and I'll try to make sure I denote what section this is coming from. So our first two examples are going to come from section 1. The first type of problem you're going to see is they're going to give you a fraction, and they're going to ask you, what are the values that would make this fraction undefined? So, something that makes a fraction undefined is if it makes 0 in the denominator. So on these types of problems, you set the denominator equal to 0. And then solve that. So we look at this one, it's x squared minus 4. We set it equal to 0, and then we solve that equation. You should recognize that that's a difference of squares, so it factors very easily to the square root of each term, one positive, one negative. Once you've got that denominator completely factored, you're going to set each factor individually equal to 0. And looks like it would be negative 2, and x would be positive 2 on that one. So what are the values that you can't have? Negative 2 and positive 2. That answers the question. Another thing from section 1 is you just were given fractions, and then you're asked to reduce those fractions. So we'll show you an example of that. It's going to be x cubed minus 4x in our numerator. Our denominator is going to be x squared plus 3x plus 2. Okay, so I'm looking at that numerator, and the first thing I notice is there is a GCF. X divides both of those. If we were to divide both of those by x, it would be x squared minus 4. I look inside of that parenthesis, and I notice once again it will factor further. It's a difference of squares. In fact, it matches the one we just did on number 1. So it would factor to the square root of each term, one positive and one negative. So I've got my numerator completely factored. Now I'll look at my denominator. It factors pretty easily because there's no number in front of that squared term. So I know I can go straight to the parentheses. My third sign is positive, so I'll adopt the sign of the second for both parentheses. So it's going to be x plus something and x plus something else. And then I remember you look at the factors of 2. There's only one way to make 2. It's 1 times 2. And those do add to 3, so we're able to drop those in. And I'll just rewrite it over here. And then from here, all I got to do is look for things that match. And if they match, one thing on top and one thing on bottom, you can cancel them out. So the x plus 2's would cancel. And looks like we'd have a final answer of x times x minus 2 over x plus 1. And remember, you can't cancel across addition, so those x's can't be crossed out because this one has an addition. If it were x times something, then yes, you could cancel those x's out, but it's not the case, so that's going to be your final answer there. So those are the types of problems you'll see in section 1. Section 2, this was whenever we multiplied and divided fractions. Not too difficult. Same kind of process we did on 2. You're going to simplify things and then cross stuff out. So let me write this problem down. X squared minus 5x minus 24 over x squared minus x minus 12 divided by x squared minus 10x plus 16 over x squared plus x minus 6. Okay, so lots of things there to factor, but they're all pretty easy because, again, none of them have that number in front of that squared term. So Let's start with that numerator. We're looking factors, again, pretty quick. The third sign is negative, so that means I'm going to have x plus something and x minus something. So I need to find the factors of 24. They are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I'm looking for the ones that subtract to make negative 5. 3 and 8, of course, are those. To make negative 5, it would be a positive 3 and a negative 8. In that denominator, again, factors quickly. My third sign is once again negative, so it's going to be x plus something and x minus something. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. I'm looking for the ones that subtract to make the understood negative 1. So again, it's going to be 3 and 4. And to make negative 1, the 3 would be positive and the 4 would be negative. Now I am dividing fractions, so you should remember you never actually divide when doing fractions. You flip the second and multiply. So we're going to change the sign to multiplication. My denominator, I'll factor it, but it's going to go to the numerator because I'm going to have to flip it. So I'm going to start with the denominator, which would be my new numerator. So again, my third sign is negative, so I know it's going to be x plus something and x minus something. The factors of 6 are 1 and 6 and 2 and 3. Looking to subtract to make the understood positive 1 this time. So that means I would have a positive 3 and a negative 2. Those subtract to make positive 1. My new denominator was my old numerator. My third sign is positive this time, so that's when I adopt the sign of the second for both. So it's going to be x minus something and x minus something else. Factors of 16 are 1 and 16, 2 and 8, and 4 and 4. Looking for the ones that add to make negative 10 or add to make 10. 2 and 8 add to make 10, so I drop them in. And now I have everything completely factored. Since everything is completely factored, I start crossing out things that match. One thing has to be on top and one thing has to be on bottom. So x plus 3s, those match. These x minus 8s match. And these x minus 2s match. So it looks like I've crossed out everything I can, and my final answer is going to be x plus 3 over x minus 4. Once again, I cannot cancel those x's because you can't cancel across addition and subtraction. You can only cancel across multiplication like we were doing in the previous step. We'll look at another one from this section, a multiplication problem. Let's see. X squared plus x minus 42 over x minus 3 times, this time, x minus 3 squared over x plus 7. Okay. So it looks like there's only one thing I have to factor this time. That would be this trinomial. It factors pretty quickly. My third sign is negative, so I know I'm going to have 1 plus and 1 minus in my parentheses. The factors of 42 are 1 times 42, 2 times 21, 3 times 14. 4 doesn't divide it, 5 doesn't divide it, 6 times 7. Which of these subtract to make the understood positive 1? 6 and 7. So the 7 would be positive and the 6 would be negative. The denominator, there's nothing to do there. It can't factor any further. So it's going to be x minus 3. This numerator, I still have a times sign. So since it's times, I don't have to flip this one like I did on the previous one. Remember what x minus 3 squared means. It means x minus 3 times x minus 3. We'll just leave it like that. It's factored. And then that x plus 7 can't do anything there, so I've got it completely factored. Now just something on top and something on bottom that matches, something on top and something on bottom that matches. Looks like I have a final answer of x minus 6 times x minus 3. There was nothing in my denominator, so I don't need the understood 1 in the denominator. Remember, if you do cancel everything in the numerator, you do need the 1 in the numerator. And that is section 2. We'll move on to section 3. So in this section, we started adding and subtracting fractions that had common denominators. So I just have one example from this section because it was really a pretty easy section. What am I on? Number 5. So it's going to be x over x squared plus 9x plus 14 plus 7 over x squared plus 9x plus 14. So you see we already have common denominators. So we just do what the numerators say. X plus 7 Those can't really go together, so it's going to be x plus 7 over that common denominator of x squared plus 9x plus 14. Remember, the denominator does not change. 3/5 plus 1/5 is 4/5. The 5s don't get added together. So we just have to check, does this denominator factor, and if we factor it, does it simplify with the numerator? So we always have to check that. So this factors pretty quickly. Third sign's positive, so I adopt the sign of the second for both. The factors of 14 are 1 and 14, and 2 times 7. Looking for the factors that add to 9. That's, of course, 2 and 7. So I factored it, and now, yes, those do cancel each other out. So I've canceled everything in the numerator. It's going to be an understood 1 in the numerator, and then the x plus 2 that's left in the denominator. So that section's not too difficult because you have common denominators. In section 4, this is when we didn't have common denominators. So you had to create those. Not too bad. 2x minus 5 over 6x plus 9 minus 4 over 2x squared plus 3x. Okay, so the first thing you want to do is look at your denominators, and if they factor, you want to factor them. So I'm looking at this first denominator. There's a GCF of 3. If you divide each of those by 3, it would leave you with 2x plus 3. In this one, there's a GCF of x. If you divide each of those by x, it would be 2x plus 3. So once you have them factored, the common denominator is found by anything that's matched. You'll just take one of them, and anything that isn't matched, you'll take each of them. So the common denominator would be the 3, the x, and the 2x plus 3. So we'll make 2 fractions, each with that as the common denominator. And we'll have a minus sign in between. So you just look from previous denominator to new denominator, what is new? So from here to there, x is the only thing that's new. So this top needs to be multiplied by x. You're going to distribute that x, giving you 2x squared minus 5x. In the second one, from previous denominator to new denominator, the only thing that's new is that 3, so it's going to get multiplied by 3, giving you 12. Now that we have common denominators, it's like the previous problem. We do what the numerators say. And this minus 12, those aren't really like terms, so we're just going to kind of mush them together. 2x squared minus 5x minus 12 all over that 3x times 2x plus 3. Now we always have to check, does this factor, and if it does, will it simplify with the denominator? So this is one of those with a number in front, so you have to make the magic number and factor a 4-term polynomial by grouping. So our magic number, 2 times 12, is 24. And the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So I'm looking for the ones that subtract to make 5. That would be 3 and 8. And it needs to be negative 5, so I'm going to break this down into a positive 3x and a negative 8x. That is negative 5x still. The other two things get rewritten. And we created that 4-term polynomial on purpose for a reason, to factor it by grouping. So we group the first two together, and we group the second two together. In the first group, what's in common? There is an x. If you divide each of those by x, you're left with 2x plus 3. In the second group, you don't want your first term to be negative, so we're definitely going to factor out a negative, and then both of those are divisible by 4. If you divide by negative 4, that would be a positive 2x and a positive 3, which is great because those parentheses match, which mean you've done it correct. So with the 2x plus 3 that's in common, and then if you were to take the 2x plus 3's, what would be left? The x and the minus 4, that's the second parenthesis. So I'm going to just kind of cross all this out because it all just turned into 2x plus 3 times x minus 4. So I look, and I notice that those 2x plus 3's match, so I'm able to cross those out. Looks like I'll have a final answer of that x minus 4 in the numerator and the 3x in the denominator. Again, I can't cancel those x's because the x is getting subtracted by 4. If it were multiplying, I could cancel them, but I can't. So that's going to be my final answer there. So it took a little bit of work, but you've been doing it for a while, so it shouldn't be too bad. Just a couple more examples here. These last two will be from section 5. Number 7. Okay, so this was solving equations. You just got done with this, so it should be pretty fresh. But I want to always provide examples just in case. So it looks like we have y over 2y plus 2 plus 2y minus 16 over 4y plus 4 equals y minus 3 over y plus 1. Okay, so again, much like 6, the first thing is look at your denominators. Do they factor? This one has a GCF of 2. That would be y plus 1 if you divide it by 2. This one has a GCF of 4. If you divide by 4, again, y plus 1. And that one already is a y plus 1. So the whole thing we want to do here is multiply by the common denominator to get rid of the fractions. So, pretty easy one. Between 2 and 4, the common denominator would be 4. Between y plus 1, y plus 1, and y plus 1, you just need a single y plus 1. So remember, you divide by the numerator, multiply what's left to the numerator. Did I say you divide by the denominator, multiply what's left to the numerator? So on the first one, the y plus 1s would cancel. 4 divided by 2 is 2. So that means I got to multiply the top by 2. That's just going to be plain old 2y. And the second one, they match exactly. So they're going to cancel each other all the way out, leaving me with that numerator of 2y minus 16. On the third one, the y plus 1s would cancel. So this top is going to be multiplied by 4. So it's really going to have to distribute, which would be 4y minus 12. From here, looks like I've got 4y for like terms minus 16 equals 4y minus 12. I want to get all my y's to one side, so I would subtract 4y from each side of the equation. And it looks like I have negative 16 equals negative 12. So this is weird. We got to stop and think about this. Does negative 16 equal negative 12? No. So this one doesn't produce a solution. There's going to be no solution that works to number 7. So no solution is our answer. And remember, on these problems, if you do get a solution, you got to plug it back in, make sure it does work. It doesn't make a 0 in the denominator somewhere. Okay, last one was just solving for a specific variable. Our equation is going to be 4a over 5b equals x squared. We're going to solve this for b. So just like number 7, first thing we're going to do is multiply the whole equation by the common denominator to get rid of the fractions. Of course, that common denominator is 5b. The 5b and that 5b would cancel each other out, leaving us with the 4a. And x squared times 5b would be 5b x squared if I put it in alphabetical order. Okay, I'm solving for b. So to get that b by itself, I just got to divide by those things that are multiplying to it. So I'm going to divide by 5x squared, which means I have to divide this side by 5x squared. And looks like I've got my solution. B equals, I'm going to flip it around, 4a over 5x squared. All right, so once again, your test is going to be a week from today. You have today and tomorrow to work on the problems to review. By the way, those problems are going to be 2 through 54 even. You're going to exclude number 46. Again, as you're working these, if you need any help, let me know. When I post the answers on Wednesday and you're getting things wrong, reach out to me. I'll help you out. Whatever you need to do to get yourself ready for that test that is Monday. We'll talk to you soon. Won't have any videos for a few days, so good luck and reach out. Talk to you later.